All right, Rheda, here we go. Um, so we got to part B. And for part B, I'm going to do what's called a motion diagram. Okay. And this, because they're asking us to find the total distance traveled. And a motion diagram will help us do that. And it just looks like this. Oops, not like that. I need a pen. Okay, so it looks like this. Okay, so we know that the particle starts at P, or a particle P starts from point 0 and moves along a straight line, or point O. So it starts from point O. Okay, and if you remember, the area under the curve of the velocity gives us the displacement, which means how far it is away from the origin. It also gives us the direction, and in other words, that the particle is going. Remember, if velocity is positive, it's moving in the positive direction. So for both this guy and this guy, it's moving in the positive direction. And anything below the x-axis, it's moving in the negative direction. So that would be to the left. So anything up here, the particle is moving right, and anything down here, the particle is moving left. Okay. So um, find the total distance traveled in the first 5 seconds. Okay, well, we got to look at a couple things here. We know from that 0 to 2, it travels, it ends up 15, it goes 15 meters to the right. Okay, so it goes, we're going to stop it here, and it's at 15 meters. Okay. And then down here, I'm just going to keep track. All right, this guy is 15, traveled 15 meters, right? And then what happened from 2 to 4 seconds? Well, it tells us in two parts here. From 2 to 4, it equals 9. And then we wrote that in on our little diagram here. It's still moving right, okay? So it moves right another 9 meters. So it's still going this way. Goes this far. Sorry for the sound effects. And 15 plus 9 is 24, right? Okay, so here comes the sort of tricky part, is what happens from 4 to 5 seconds. Well, they tell us that S of 5 is equivalent to S of 2, right? S of 5 is equivalent to S of 2. So that means that at the end of 5 seconds, it has the same displacement as S of 2 did. And S of 2 had a displacement of 15 meters. And before I continue, let me just write in here that this distance is 9. Okay. Well, that means it makes a U-turn. Actually, it goes straight back, but on a motion diagram, we can't do that. And it goes to here, right? And I know it's going left because from 4 to 5 seconds, it's under the curve, okay? Well, if it goes back from 24 to 15, that's another 9 meters, 9, right? So the total distance is 15 plus 9 plus 9, which is 18, 20, 33. So the total distance traveled is 33. Okay, so now we went here and we got the probability. I explained to you that the total area under a normal distribution is 1. And then we also talked about how we can find the probabilities by finding the area under the curve. So the probability that a randomly selected value is less than negative 1.6 is equal to A, right here, where A is the area under the curve to the left of negative 1.6. And the probability that a randomly selected variable is greater than 2.4 is the area of this gray which is represented by B. Okay, so I just wanted to make that clear. And that's why we were able to say that the probability of this green area is 1 minus the sum of A plus B, because again, the total area all the way under the curve is 1. Okay? All right, so I'm going to go, I clean this off. We need a little bit of a clean slate here to do this one. Okay? So given that the random variable z is greater than negative 1.6, okay, now let's just hold it right there. this is conditional probability, okay, and if we know that the probability is greater than negative 1.6, then this is no longer part of the question, because we know that the answer is somewhere here. It's somewhere here. It's only the green part, okay? This is the same idea is if I have, I don't know, let's say 3 red marbles, 4 blue marbles, and 5 green marbles, if I know that if I'm given that, well, okay, a marble is randomly drawn from the jar, and it's given that it's not green. Well, we would the 5 green marbles are out. They're out. I know it's not green, so they're not part of the total. And I asked you, what's the probability of red, that a red marble was drawn? Well, it would be 3 out of 3 plus 4, because those are the only marbles left if the greens are gone. Okay, so by them saying, given that the random variable z is greater than negative 1.6, this guy is out. He's out, 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 out. We don't consider him anymore. Okay, find the probability that z is less than 2.4. Well, what the heck does that mean? Well, that means that we're trying to find the probability let me do a different color. We'll go green again, okay? We're finding the probability that the random variable is somewhere between negative 1.6 and 2.4, given that it's definitely above negative 1.6, okay? So let's just think about this. The total possibilities are all of this, right? It's like I am removing the green, like this example here, I'm removing the green marbles. All that is left is everything to the right of that. Well, the area of everything to the right of that is 1 minus a. Remember, the total area under the curve is 1, and the area to the left is out of there, so the total is 1 minus a, right? So think of 1 minus a as the same as all I got left are blue marbles and red marbles, okay? Now, the probability of success is just this green area right here, right? And if you remember, the green area, boom, 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 was 1 minus a plus b. We did that in the previous question. And so if that would be the successful area, so that goes on top. Just like the 3 goes on top, because that's the successful draw when we were asking the probability of red. Well, there's 3 chances. Well, the only chance that the area is green is 1 minus a plus b. That's the green area there. Hopefully that makes sense. Okay. So now we're going to go to a new screen because I don't think we need it for C and D. Okay. Now whenever you have multiple steps to a question in an IB problem, they usually sort of hold your hand, not hold your hand, or they kind of guide you through this, right? Like, for example, we were able to use the answer from A to get B. That's almost always the case. Okay. The second thing here is that unless explicitly stated, and I've never seen this happen, any letter or variable used to represent something represents it all the way through. And here they reference A, right? Well, this A is this area. Okay, so before we started, I just wanted to make that point, right? They said A here, they are talking about this area. Okay. All right. So, um, and before we move on, I want to talk about what a standard normal distribution is. Okay. If I have, where do I want to go here? I want to add a, oh, here. You can't see that. Okay. So I can have a normal distribution and I could have a mean of, I don't know, like 12 and a standard deviation of 6. And if this is, so if the mean is 12 and the standard deviation is 6, that means 18, 12 plus 6 is 18, and 12 minus 6 is 6. That means that every all possibilities within one standard deviation are right here, plus 6, minus 6. Now, a standard normal deviation, okay, this is just a deviation, did I say? Distribution. Oh my God. A normal distribution looks, could be this, but a standard normal distribution has a mean of 0 and a standard deviation of 1. Okay? And there's a way that we can convert, like this 6 here, we can convert it to a number on the standard normal deviation. So this is plus 1, minus 1. So 1 and negative 1 would be over here. For the standard normal distribution. Okay, and there's a way to convert from a regular normal distribution. We can convert these numbers to a standard normal distribution, and that is z equals x minus mu, the mean, over the standard deviation. Okay, and that formula is in your formula book, and it's right here. X minus the mean over the standard deviation. Okay, now I say that because we need to immediately recognize that this guy is a standard normal distribution because its mean is 0, ka-ching, and its standard deviation is 1. Okay. So that means the mean is 0 and the standard deviation is 1. So these are all the standardized numbers along the horizontal axis. Okay. So this negative 1.6 could have represented, I don't know, just about any number. Like this could have been maybe the 12 before, and because of the mean and whatever the standard deviation was, we could plop it into this formula, and the z, think of this as like the z-axis. Z is 0, z 2.4, negative 1.6. The z would turn out to be negative 1.6. Hopefully that makes sense. It's a lot, but hopefully it makes sense. Okay. Now, it says part C, well, a second random variable x is normally distributed with a mean m and a standard deviation s. It is known that the probability that x is less than 1 is equal to a. All right. Well, a is right here. Yes, it's right there. So if that's true, then the standardized value for x equals 1, that's what this guy is, has to be negative 1.6, because negative 1.6 is where the probability is A, right? The probability is equal to A. This probability is equal to A. This is a standard normal distribution. Standard normal distribution. Boop, boop, boop. So I know that if the probability is equal to A, then the standardized variable has to be negative 1.6. They also say write it down. Write down, and it's only worth 1 mark. So that means it's staring you in the face. You shouldn't have to do any work when it says write down. Okay? Now, it's also known that the probability that x is greater than 2 is equal to b. And they're asking us to find the standard deviation. So that's where this guy is going to come in. Okay? So we know that the standardized variable for greater than b is 2.4, right? Because here's b, right? So for z equals x minus mu over the standard deviation, and I'm going to replace this because the mean is m and the standard deviation is s. So I'm just going to use what they've given us. These are just the Greek letters, m and s. Okay, so I know that this z is equal to 2.4. Okay, and I know that the x is 2 because that's the x value. So that equals 2 minus m, the mean, over the standard deviation s. Now, I have two unknowns. I have m and I have s, okay? Now, by the same argument, I know that the negative 1.6 is equal to the standardized variable 1, or I'm sorry, the x. This is the x, not the standardized variable. The standardized is negative 1.6. The x value would be 1 minus m over s. So now I have two equations and two unknowns. So life is good. Let's extend the page a little bit. Okay, and so if I multiply both sides by s here, I get 2.4s equals 2 minus m. And here I get negative 1.6s equals 1 minus m. I'm solving for s. So all I have to do is solve for m and plug it in to one of these. I guess I'll do this one. So 2.4s minus 2 equals negative m. Dividing everything by negative 1, negative 2.4s plus 2 equals m, which I am then going to plug into this m. And I get, let me give myself some more room, negative 1.6s equals 1 minus negative 2.4s plus 2. Little algebra, 1.6s equals 1 plus 2.4s minus 2. If I subtract 2.4s, I get negative 4. 2, 3, 4. So negative 4s equals 1 minus 2, which is negative 1. Divided by negative 4, s is equal to 1/4 or 0.25. All right, I hope that makes sense. If I don't see you tomorrow, good luck on your exams. You're going to do great. Don't worry about it. You're going to be fine, I promise. All right, if you can, remember to shoot me an email. Let me know how you do.